Recording in progress.
Okay, so today, I think this is a kind of like a 2-day event here. There's lots of problems, lots of thinking questions. All right, lots of formulas that you're supposed to remember. All the formulas for perimeters, for areas, for all those types of things. Plus, this goes back to the good old days in 6th grade. We have to name figures. You have to be able to tell me if it's convex or concave, if it's regular or irregular. So today, probably I'll just skip through and do the odds. And then tomorrow, we're just probably going to do the what? Probably going to do the evens. All right. I also ordered graph paper for everybody, but it hasn't come in yet. All right. So it should have been in, but it's not. So when we do the graphs, you're just going to try to sketch it to the best of your ability. All right. So here we go. Number 11. First of all, 11 is called a what? If we name it by sides. Yes, obviously it's a triangle. All right. Now, the next question is, classify it as if it's convex or concave. Can anybody tell me what the difference is? All right, well, all triangles are going to be considered convex. All right. And something is regular if all sides are congruent and all angles are congruent. So this is called a convex. It is considered regular, and it is considered a triangle. All right. Now, I didn't do a very good job explaining concave and convex, but I will be able to on the next figure. All right. Now, of course, we call it a triangle because it has 3 sides. What do we call something with 4 sides? Let's just review that.
Quadrilateral.
Quadrilateral. Exactly. What do we call something with 5 sides? Pentagon. That's good. 6 sides. Hexagon. 7 sides. Heptagon, correct. 8 sides. Very good. 9 sides. It's called a nonagon. All right. Nonagon. 10 sides. Decagon. And then 12 sides. 12. What? 12 sides is a dodecagon. You're correct. All right. Now, listen for me. Generally, I don't care about 11, 12, 13. After you get so many, you just call it, if there's 13 sides, you just call it what? 13gon. Or 20 sides is a 20gon. All right. Things of that nature. But generally, welcome.
Hello.
All right. Yes, good morning. All right. So now let's look at question number 12. All right. First of all, how many sides does 12 have? Everybody agreeing it's 7 sides? So that's called a what?
Heptagon.
Heptagon. Now, is it convex or concave? It is definitely concave. Thank you very much. Now, the formal definition of concave is when you draw the diagonals. If it's convex, all of the diagonals will end up inside the figure. It's concave if you can draw a diagonal and it is outside of the shape. All right. So right
Mr.
now,
Travis,
yes,
what worksheet is this?
this is not a worksheet. It's out of the book.
Okay, thank you.
So we're working out of the book today. And until we do reviews, we're always going to be working out of the book.
Okay.
All right. So now this diagonal that I'm drawing so far is in the interior. And remember, a diagonal is just a segment that is drawn from one vertex to another vertex. However, the reason it's concave is because if I draw from here to here, that diagonal is where? Outside of the shape. So this is considered a heptagon that is concave. And is it regular or irregular? It is definitely irregular. Now, remember, you are regular if all of your angles are congruent and what? All of your sides are congruent. So in this figure right here, notice all the sides are congruent. Is everybody with me? But is it regular? No, because the angles are not. All right, very easy. All right, now for 13, that's called a what?
Octagon.
It's called an octagon. All right, it's an octagon. Is it convex or concave? Concave. Is it regular or irregular? What is it? Does it look regular? Is this, is this angle right here the same as this angle right here? No. All the sides are correct, are congruent, but the angles are not congruent. All right, so it is definitely irregular. So it's an octagon, and it's what kind of concavity? Is it concave or convex? Definitely concave, and it is irregular. Question 15. I'm on 15, yeah. How many sides? 11 or 12? 11. Undecagon is 11. All right, I'm not going to ask you that, but that's what that's technically called. Now, undecagon has 11 sides, and here we would say it's what? Concave. And then we would also say that it's what? Yeah. All right, super easy. All right, so now we're just getting into naming shapes. All right. So now we'll continue working on the odds. All right. Now everyone should be able to tell me about perimeter. And perimeter is the same if you call it the what? Circumference and circumference and perimeter mean the same thing, except circumference is for a what? Circle. Because are there any sides to a circle? No, there are no sides. All right, so perimeter is the sum of the sides. Circumference is the perimeter of the circle. All right, can anybody remember what the formula for circumference is? It's been a while. Now remember, what the way I remembered it is squares measure what? Squares measure area. All right, so it can't be pi r squared. All right, it's pi d. So if you want, make sure you write this down. Circumference is pi times the diameter, or it can be written as what else? The other formula. Diameter. Diameter is what? Yes, 2 pi r. All right, those are your options there. All right. To me, if they give you the diameter, just multiply by pi. If they give you the radius, multiply by 2 and then multiply by pi. Same thing. All right. So again, you have to know all these formulas. All right. I'm never going to put them on the test. All right. You have to know the formulas. So if you don't know them, kind of make yourself a note. all right, kind of review them, all right, because on the next test, all right, you're responsible for all of them. So now, if we want the perimeter here, that shouldn't be a big deal. Perimeter is equal to what? What? What is the perimeter? We can do the mental math on this. I've got a 7.2. I don't think that's right. Anybody else?
Oh my God, I'm so sorry. I meant
7.8 what?
meters.
Yeah, 7.8 meters. Now, to me, I would like you to remember perimeter is twice the length plus the width. Now, in the past, we just write 2L plus 2W because there's two lengths and two widths. But now that you're a little bit more advanced, you can see that the length and width, if you add and multiply by 2, to me, it's easier. All right. So if we're looking at, let's just look at 18 real quick. So what do we got for 18? Circumference equals what? Pi d. All right. So if you don't know that, or if you forgot it, write it down. So your circumference is equal to what? 8 pi. All right. And then we say 8 pi inches. Now notice in the directions, it says round to the nearest 10th. As you become more advanced, we do not round. All right. So pi is the answer. All right. So the correct answer is just what? 8 pi. We know pi is roughly 3.14. I know everybody can do 8 pi on the calculator. We don't need to do that. All right. We want the exact answer. That's why we write in fractions. All right. We try not to round. All right. We try not to round. All right. So for question 19, all right, the perimeter is what?
26.
26. Thank you very much. 26 what? Inches. All right, 26 inches. Anybody have any trouble yet? All right, don't feel bad. And I'm sorry we did this in 6th grade. All right, should be easy. All right, now we definitely have some problems. All right, why do I have problems with 21? Tell me.
We don't know what the other side is.
We don't know. And what's that other side called though, James? Yes, you do. What is this side called? Someone else help him. Starts with an H, you're right. Yay, very good. It is considered the hypotenuse. It is considered the hypotenuse. And obviously, if that's the hypotenuse, the other sides are called the what? The what? No. What are the other sides called? And then I'm going to tell you, then you can tell me what the formula is. If that's the hypotenuse, the other sides are obviously called the what? Oh my gosh. They're called the legs. All right, obviously, right? How do you not know that? All right. The hypotenuse and the legs, those go together like apple and pie. They're always together. The hypotenuse and the legs. I don't know why you don't know that. All right. Now, Harrison, tell me the formula. Yes, a squared plus b squared equals c squared, because we're trying to find the hypotenuse is c. Now, of course, we're not using our calculators right now. All right, we're going to give it a little rest. All right, make sure you're good with your mental math. All right, so I'm always trying to convince kids that fractions are easier than decimals. So 6.5 is the same as what fraction? We don't do mixed fractions. We do improper fractions. Yes, so I want everybody to write that as 13 over 2. And then obviously 4.5 would be what? 9 over 2. If you don't know that, now's the time to speak up and get back in the game.
How did you get that?
Well, 9 divided by 2 is 4.5. Right? 9 divided by 2 is 4.
Oh, gotcha.
Right? If
Thanks.
you don't know that, you can say it's 4 1/2, and then convert the mixed fraction to an improper fraction. All right? Which is what you did in like fifth grade. All right, so I just got kicked off the screen for now. It's having issues. That's why I'm getting a new device put in here soon. All right. You still there, Marion? All right, I'm just having trouble with my board, so everybody's gonna have to listen to me. All right, until it decides to do better. All right, now, in this case, what is A and what is B? And what is C?
6.5A.
Yeah, but we're gonna call 13 over 2 A. Can it be B?
Yes.
Yeah, it doesn't matter. The only one that matters is the hypotenuse. So if that is the hypotenuse, I need everybody to write down 13 over 2, put that in parentheses squared, plus 9 over 2 squared is equal to C squared. Everybody good with that? What are we waiting on?
How do you, when we change like the 6.5 to 13 over 2, how do we like change it to a fraction?
6 1/2. 6.5 is 6 1/2. Do you agree? 2 times 6 plus 1. 13,
I get it.
right? But again, that's just practice, review. All right, so now we have to square, obviously, without a calculator, 13 over 2 squared. What's 13 over 2 squared?
69 over 4.
Yes, everybody should know that, 169 over 4. That wasn't that bad, 169 over 4. All right, now part of the reason we're not using a calculator is because eventually you're going to be taking some standardized tests that don't require calculators. All right, these are the kind of things you got to be good at, mental math. All right, now I need everyone to tell me what's 9 over 2 squared. Right, so I have 81 over 4 equals C squared. Anybody have any issues with that? All right. Now we're adding those together, which is obviously what? How much? 250 over 4 equals C squared. Now, to solve, actually, listen, we could reduce that fraction by 2, right? But I also know that I'm going to be taking the square root of C squared, right? And so if I take the square root of C squared, I'm going to be taking the square root of what? 4. And is square root of 4 a perfect square? Yes. So if you reduce it, it makes the problem a little bit more difficult. So what I want everybody to do is leave it alone and just take the square root of both sides. Now, when we take the square root of both sides, I end up with C equals the square root of 250 over the square root of 4. And what is the square root of 4? 2. Now, I have to break down the square root of 250. Who remembers how to do that from last year? Square root of 250. Tell us, come on.
Is it 5 radical 10?
You are amazing. 5 radical 10. That's exactly what I want to hear. Thank you so much. 5 radical 10. Now, if you're one sitting there going, I don't know where he's getting that from, right? You can let me know. What?
How did you do that?
Because 250 is 25 times 10. So you're breaking down 250 into 25 times 10. And then what's the square root of 25? And that's how I got the 5. And the lonely 10 stays behind in his house because he has no one to go out and play with. All right, that's how I remembered all this. Square roots, you have to go out in pairs or you can't go out. All right, 25 is 5 squared. All right, so that comes out as a 5. So guess what? That 5 radical 10 over 2 is the hypotenuse. That is the way I would like you to leave it. All right, we're trying to find exact answers when possible. All right, anybody have any questions with 21? All right, now let's move on. What?
Are we supposed to find the area for it? Or is that, or are we supposed to find the failure report?
What is it? Oh, thank you so much. I made a mistake. All right, each one of these figures, we're also supposed to find the area. So let's go back now. Thank you very much, Harrison. I appreciate you. Area.
You made a mistake, Mr. Stroh?
No, I didn't read the directions. Thank you.
That's a
That's a
mistake.
mistake.
So area, come on, people. Tell me the area. All right. Now 2.8 times 1.1. All right. So off to the side, you can multiply this out, or you can remember the rule I taught you how to multiply by 11. Remember, when you multiply by 11, you write the last number first. That's an 8. Then you add these two numbers together. What do those two numbers add up to? 10. So you put a 0, then you carry the 1. And then normally you put a 2, but there was a 3. So it's 308. 28 times 11 is 308. Then how many places do you move the decimal? 2. There you have it. 3.08. 3.08. So area is 3.08 meters squared. Okay? Anybody have any questions with that?
Can you do that again?
Yeah, whenever you multiply by 11, you put the last number down, you add the digits, and then you put the first number down. So normally it'd be 2, 10, 8, but this 10 can't be there. So that's a 0, you carry the 1, 308. All right, so anytime you multiply by 11, let's say 27 times 11. Everybody should be able to look at that and say that's just 297. The 7 goes down, add, and then keep the 2. All right, if it goes over 10, you just put the number and carry the 1. For example, just another chance. Let's say 38 times 11. Put the 8 down, 3 plus 8 is 11, so it's 418. It's really simple. People think you're crazy because you can multiply by 11. It's just a pattern. All right, simple as that. All right,
Okay.
so now let's look at number 18. All right. So the area of a circle was what you guys were trying to tell me. What's the formula for area of a circle?
R squared.
Yes, pi r squared. So now what's the radius?
4.
4 squared is,
16.
so now I'm at 16 pi inches squared. All right, 16 pi inches squared. Everybody okay with that? Now, everybody knows my feelings. I'm not really feeling like multiplying 6.5 times 6.5, right? So we already know that 6.5 is what? What fraction, everybody? 13 over 2. Now you understand why multiplying by fractions is much easier than decimals, because now we know the area is what? What's the area, guys?
26 over 2.
What? What?
Oh.
Area. What's the formula for area of a square? That's exactly correct, Harrison. Side squared. So what is 13 over 2 squared? Wow, that's why it's easier to deal with fractions. 169 over 4 inches squared. And now you should be able to look at that and say, well, that's 42.25. All right, so people look at you like you're crazy because you can divide by 4. All right, not a big deal. All right, but again, we work in fractions because fractions are easier to work with. All right, anybody have any questions? All right, now 21. What's the formula for area of a circle? Or I'm sorry, area of a triangle? 1/2. 1/2. Say it. Yeah, 1/2 base times height. Now, how I remember that is I always remembered that a triangle is just half a rectangle. Does everybody agree with that? So that's how I remember the formula for a triangle. All right, so for 21, 1/2, what's the base? Nope. What's the base? Correct, 9 over 2. What's the height? 13 over what? 13 over 2. All right. So now we know that our area is something over 2 times 2 times 2, which is what?
8.
Yes, today it's 8. All right, now you have to do 9 times 13 in your head. And obviously that's what? 117. Thank you so much for that information. Remember, 9 times 10 is 90. 9 times 3 is 27. 90 plus 27 is 117. All right, that's how you multiply a single digit by a double digit. So now we say 117 over 8 what?
Centimeters squared.
Centimeters squared. All right, perfect. All right, again, thank you for that, Harrison. All right, moving on. Question 23 now. Let's see what we're doing. So Elaine purchased 4 yards of lace trim for her local or from her local fabric shop. She has a circular tablecloth that is 54 inches in diameter and a square tablecloth that is 40 inches on each side. Can she trim either tablecloth? So she has 4.5 yards, but over here we're dealing in what? Inches, which is kind of annoying, right? So we have to remember how many inches in a yard. Can I remember that?
36.
Yes, 36 inches. So if you have 4.5 yards, to me, that's easier to convert to inches. All right, 4.5 yards is what? Come on, practice that mental math. Let's go. 100 what? Wait a minute. So first of all, let's do 36 times 4. So anytime you multiply by 4, to me, doubling is easier. So 36 times 2 is 72. Then 72 times 2 is 144, correct? So 144 inches is 4 yards, but we also have a half a yard. So half a yard would be what? 18 inches. Thank you. You're adding 144 and 18. Now, if you want to know how to add 18, add 20 and subtract 2. So what's 144 plus 20? And then minus 2. So you have 162 what? Inches. All right, you have 162 inches. All right, so let's look at the square tablecloth because that's the easiest. If you have a square tablecloth that is 40 inches, can you put the trim on there?
Yes.
Yeah, right? Because you would need how many inches? 100 and what? 160, right? All right, guys, come on now. If you're sitting there going, he's crazy, all right, it would be nice if you just said that you don't know what I'm saying. Because you may have any problem with me saying yes to the square tablecloth. Now, I have a circular tablecloth that has a 54-inch diameter. Am I going to be able to use that? Could I put the trim around that? Obviously what? Nate, obviously what? Why? Is over 162. All right. I don't know if that's true or not. So let's look in 54 times 3. What's 54 times 3? 160 what? 162. So that means that pi is too much, right? So the tablecloth is definitely a what? The circular tablecloth is definitely what? No on circle. Yes on square. So again, practicing your mental math, guys. All right. if you're having trouble with your mental math, just let me show you, let me teach you. It's not really that difficult. All right, so I'm good with 23. Okay, now let's hold up on 25 through 28 till tomorrow. I'll have graph paper for you tomorrow. If not, I'll print some out and give it to you. All right. Anybody have any issues with that? All right, let's continue on. Let's look at 29 now. Oh, this is easy. All right, 29. What is the perimeter? 14 what? 14 feet. And the area would be what? 12 what? Nope. 12 what? Yes. Right, you
How is it
measure,
14 feet.
say that again?
How is it 14 feet?
Perimeter is you add up the sides. Or you know a formula,
Oh, okay. Never mind.
right? The area of a rectangle was, remember, anytime you're measuring area, you're measuring with squares, okay? Now it says, suppose the 4-foot length was doubled. So what effect would this have on the perimeter? Anybody? Yeah, I'd definitely make it bigger by how much? Yeah, 8 more, right? 8 more feet, right? Why is it 8 more feet? Because you're just adding 4 to 2 lengths, right? So for C, increase perimeter by 8 feet. But what would it have? What effect would it have on the area? What would effect would it have? Yeah, it would actually double the area. And we're going to talk about that in like chapter 12 more. I don't know why they're kind of introducing it in chapter 1. That's one of the last things we cover. All right, so the area would double. All right. Now, suppose the length and width of the rectangle are doubled. Then what would happen to the perimeter? Yes, I'm happy. The perimeter would double, right? The perimeter would double. And if you're not sure, you could just change it to 6 feet and 8 feet and see what that does to the perimeter. However, what's that going to do to the area? Quadruple, that is correct. Quadruple, or multiply the area by 4. Multiply the area by 4. All right. And that will all get explained in a later chapter. All right. But I guess they're just wanting you to make some observations here. Let's say you didn't know that. All right. If you double, it would be 6 by 8. And 6 times 8 is what? 48. And then you're comparing that to what? 12. So you should be able to look at that and say, well, that's just 4 times larger. Everybody okay with that? All right, here we go. What time do we get out? 9:00 something. All right, here we go. 9:04, thank you. So on 31. All right, here we go. It says a rectangle has an area of 30 square yards. And it's 10 times as long as it is wide. Find the length and width. Someone. All right, so again, let's practice drawing things out here. Let's make a rectangle. So the area we know is, The area we know inside here is 360 square yards. So the width we could label as what? X. And the length we could label then as what? 10x. All right, does anybody have any problem with that? All right, now again, labeling is one of the most important things I can teach you in geometry. To organize your thoughts, you got to draw the shape. All right, put things in. It's not always simple to see. If you draw the picture out, label it properly, it's very simple. So what would be the area of the rectangle in terms of X? Someone tell me. 10x. What? The area would be,
11x.
come on. Haven't heard the right answer.
10x squared.
Thank you, Harrison, 10x squared. Because again, remember, area equals length times width. So 10x times x. Remember, when you multiply, what do you do to exponents? You add them. That is correct. So the area is in fact 10x squared. And now that is equal to numerically what? 360. Thank you. That's what that means. All right. Algebraically, it's 10x squared. Numerically, it's 360. Those are equal. So now everybody can obviously look at that and say, because they're asking about the area, right? So you multiply length times width to get the area. You with me on this or not? Make sense? All right. So now from the here, we just say, what do I do with the 10? Divide. All right. And so now we're looking at this saying x squared equals 36. So x equals 6. Anybody have any issues? Anybody? But of course, that's not the answer, right? So you would say, now again, you'd have to label it. The width is equal to what? 6 what? Yards. And the length then would be what? 60 yards. So I'm happy. Okay, so I think I've done a good job today, if I do say so myself. All right, so I really want you to try to do the what? I want you to really try to finish up the odds. For those of you guys who are kind of motivated, you can go back and kind of look through some things. Tomorrow, we're just going to go through the what? We're going to go through the evens. Now, if somewhere along the lines you have graph paper, right? I don't mind you trying 25 and 27. All right. But again, it's just drawing them out. And that's kind of annoying without graph paper. That would be, oh, wait a minute. Let's just do this. Let's go ahead and open a Notability and we'll just do it on Notability. All right. Yeah, we got a few minutes. I'd rather go ahead and knock this out so we have less work. All right, graph each figure with the given vertices and identify the figure, then find the perimeter and the area of the figure. All right, so everybody go to Notability. All right, add a note and then change it to graph paper. Does everybody know, do you remember how to do graph paper? All right, then just make yourself an X and Y axis. If you're not sure, you click the 3 dots and then paper comes up. And then you just convert your paper over to graph paper and make it the small graph paper. All right. Now let's go ahead and plot these points. So -2, -2.
I can't find that page in the book.
I don't know what you mean.
What page in the book did you find those problems on?
Yeah, these problems are at the top of the page, 61 and 62, 11 through 42. Section 1-6. Is that right, guys?
Okay, it must just be my book then.
Well, all the books are the same. I mean, I copied it. Oh yeah, Marin, it doesn't have the graphs. I added the graphs myself. Do you see the problems? Okay. So now once we're here, we're just going to connect the dots. And again, all right, this is kind of annoying. So tomorrow we have a lot of work. All right, because these problems are annoying. All right, what time? The bell rings at what time? What? Okay, so we'll just stop there. All right, you will tomorrow have the graph paper for you. All right, try to do the odds, finish up the odds. I really like the paper. I really appreciate you guys today, guys. Outstanding. All right. So we'll pick up tomorrow. All right, Marin. When are you coming back, kiddo?
Next Monday.
All right.
I have a quick question. What's concave and convex?
What?
What is concave and convex mean?
Concave. Well, that's the bell, Marin. Just it's really simple. I'll tell you tomorrow.
Okay.
All right.
Okay. Bye.